Hello, my name is Akash Patel, and today I will be talking about environmental conditions on Mars. Since Mars is environmentally different than Earth, we humans cannot just set foot on Mars and expect to frolic around. There are many conditions human explorers and colonizers need to consider. In this presentation, I will be discussing some of the most important ones. Geology is the first major environmental factor I will be talking about. The geology of Mars mostly consists of the terrain and its composition. I'll explain features such as the regolith, permafrost, dust, and various landforms, among other things. The Martian terrain includes mountains, hills, valleys, and canyons. It also contains craters, dunes, and gullies. On a smaller scale, boulders and rock fields are also part of the terrain. The terrain is crucial to know because it determines safe landing zones and proper navigation routes. The regolith is the top layer on the surface of Mars. Because of the many meteorite impacts and surface weathering, the regolith contains rock fragments of various sizes and compositions. The biggest problem that arises due to this is mobility. The regolith may cause instability, collision, or immobility for both humans and rovers. Another potentially dangerous part of the terrain is the permafrost. Permafrost is a permanently frozen ground. On Mars, some of the surface features are speculated to have been caused from the thawing and freezing of this layer. If Mars heats up from colonization, then this scenario will likely and may cause massive structural damage. The Martian soil is not like organic Earth soil. It is fine-grained with sand-sized particles. It is composed of iron oxide, sulfur, and chlorine, among other potential toxic materials. This soil can cause toxic effects for humans and corrosive effects for machinery. Lungs can be damaged from acidic dust, and strong oxidants are also a hazard. Airborne dust is a major problem for human operations due to its ubiquity and pervasiveness. The hazards occur from dust intrusion and adhesion. Even during a calm day, there is always a certain amount of dust in the Martian air. Dust can cause failures in astronaut suit seals. They can also clog filters, decrease visibility dramatically, and even accumulate an electric charge. Dust would be able to degrade and corrode sensitive electronic and mechanical equipment. The Martian landscape is filled with impact craters. These craters can be extremely expansive. It is important to know the position of these craters for the benefit of colonization. Volcanic features are another feature to look out for. Although they are not an immediate threat, it is vital to know the location of places that can be dangerous in the future. The polar regions could also be volatile in the future, where colonization efforts can be common. One thing that is a major concern on Mars is the radiation. Due to the thin atmosphere of Mars, radiation from space can easily penetrate through. Radiation can come from cosmic radiation, solar storms, or even future power sources, like nuclear sources. Radiation can cause cancer and genetic mutations, among other health issues. The next major environmental factor I will be discussing is the climate of Mars. Around 3.5 billion years ago, the climate of Mars was similar to a hot and wet young Earth. Now, it is much colder and barren. I will talk about the temperature, seasons, atmosphere, and various other conditions. The temperature on Mars is colder than the temperature averages here on Earth. Daytime temperatures range from -71 to -53 degrees Fahrenheit, while nighttime temperatures can be from -184 to -85 degrees Fahrenheit. This extreme cold may cause mechanical failure, and direct human exposure will not be pleasant. Just like Earth, Mars also has seasons. These are caused by the axial tilt of roughly 24 degrees, which is very similar to Earth's. Since Mars has a more elliptical orbit, the amount of sunlight also changes throughout the Martian year. This is important because colder conditions and less sunlight should be taken into account for the successful operation in a specific area on Mars. The Martian atmosphere is very difficult from Earth's. It is 95% carbon dioxide, 3% nitrogen, and 1.6% argon, with small amounts of various other gases. Because of this composition, it is crucial to have a suit that can also provide for human respiration. Martian atmospheric gases themselves do not pose large toxic risks. However, due to the amount of airborne dust present in the Martian atmosphere, the air can be very dangerous. The dry conditions and unknown conductivity can also cause potential electrostatic hazards. Winds are much stronger on Mars as well. The highest recorded wind speed has been 60 miles per hour and the average is around 20 miles per hour. These winds can cause regional and even massive global dust storms that can last a while. Explorers and colonizers should always be cautious of sudden increases in wind speed. The pressure on Mars is also much lower than Earth's. The pressure on Earth averages 1,013 millibars. This is more than 100 times the average Martian pressure of 7.5 millibars. The low air pressure on Mars can cause the eardrums to rupture, and any liquid on the surface of the skin would instantly vaporize. From the environmental conditions I've just described, you can see how fundamentally different Mars is compared to Earth. Because of these conditions, Mars' impact on human life is drastically different than what we know of. Overall, humans are in danger if unprotected in the inhospitable Martian environment. All in all, when the first human explorers and colonizers set foot on Mars, they should do so after careful consideration of all these factors, from the rough terrain to the fine dust, from the cold temperatures to the high-speed winds. These are conditions that should be carefully considered prior to any sort of operation on Mars. Thank you.